The corrosion here is significant, especially on the joints. This mortar base is remarkably intact, despite the calcification.
We're clear on the port side. Start the tension sequence now, slowly. All right, steady now. Bring her up slowly, watch the straps.
That one finally let go. The corrosion here is extensive, but the casing itself seems structurally sound beneath the marine growth.
Apply the heat evenly across the collar. Okay, hitting it with the penetrating fluid now.
This ultrasonic tank uses high-frequency sound waves to remove the corrosion without damaging the underlying metal. We use the lapping table to achieve the perfect flatness required for the swash plate piston. It's a delicate process.
We have to check the rotational runout here. If it's outside tolerance, the alignment shim needs adjustment. Look at that! The swivel joint finally cleared. We've got pressure. All right, the swivel is rotating smoothly. The seals are holding pressure perfectly.
And that's the last adjustment. The mortar assembly is finally complete, ready for preservation. Tracing this schematic confirms the initial failure point was likely within the planetary gear system itself.
Gauges look good. The alignment on the elevation mechanism is within tolerance.
We're seeing significant pitting corrosion here. The galvanic reaction with the lake bed is quite evident after all these years. We have to be extremely careful not to damage the underlying metal. This removes the heavy scale, but we need to assess the corrosion underneath. After removing the initial layer of grime, we use the dial indicator to check for structural integrity and alignment before proceeding. The ultrasonic tank uses high-frequency sound waves to create cavitation bubbles, effectively stripping away the marine grout without damaging the underlying metal. Look at that! The runout is minimal. This gear is perfectly reusable after 70 years underwater.
Now we apply pressure to the manifold. Watch the main gear synchronization. It's moving smoothly.
The mechanical override is functioning correctly. We have clearance on the internal gear.
We apply the clear coat first, then use this sealant on the perimeter seam to prevent any moisture ingress down the road.
The distortion on the lower frame is stable at 0.02 millimeters. Recording the measurement now.
Surface, this is dive lead. Tension is good. Start the ascent.
The pneumatic grinder allows us to remove the heavy corrosion layer by layer. We then use the calipers to check the remaining structural integrity.
We've got the tension verified across the perimeter now. It's holding strong.
The engineer meticulously primes the hydraulic system, bleeding air from the lines to ensure structural integrity during the salvage operation.
We're checking the runout on the upper ring. Any deviation here could compromise the entire assembly.
Steady pressure now. Checking the runout on the dial. Yes, minimal deflection. That's exactly what we wanted to see.
All right, engaging the hydraulic power pack now. Pressure's building steadily, checking the fittings for any micro leaks. We have to be incredibly precise here. Any remaining corrosion in these detents could compromise the whole assembly. These fittings have to be precise. We use the calibrated torque wrench to make sure the hydraulics are properly secured to the elevation cylinder.
Keep pumping. Okay, cracking the bleed port now. There's the oil, seal it up.
The inclinometer is zeroed. We'll now check the full range of motion on the elevation mechanism. We're slowly bringing the cradle up now, watching the pressure stabilize right at the 45-degree mark. Wiping the rod now, and as you can see, absolutely zero fluid leakage. The seal is holding perfectly.
After greasing the teeth, we cycle the mechanism to ensure even distribution and silent engagement. Looks good.
The caliper reading confirms deep surface oxidation. This will require electrolysis before we can stabilize the metal.
This bore cleaner ensures we don't miss any micro fractures during the forensic examination. Easy now, take it up slowly. Watch the alignment on the swivel frame. Just a fraction more to the left. We're fitting the main hydraulic return lines now. It needs to be torqued precisely to the manufacturer specs, otherwise we risk cavitation.
Okay, the pressure is holding steady at 1500 psi. No weeping from the seal ring. This confirms the structural integrity of the cylinder.
And that's exactly where we need it. The alignment is precise to the micron. Look at that! Flawless articulation across the full range. She's ready.
The challenge was stabilizing the corrosion without altering the historical integrity of the mechanism. The hydraulics are fully engaged now. Looks like the swivel mechanism is holding pressure perfectly. That's a successful rotation.
Pressure is holding steady. No leaks at the swivel joints. We are good to proceed.
Okay, the swivel base is centered and the safety pins are engaged. That should hold it securely for transport. If we follow the red line here, it bypasses the collapse zone. That's our safest approach to the wreck.
These plans detail the hydraulic system. We need them on site if we hope to lift her off the seabed intact.
Lock down those clamps tight. We need this hydraulic system secure before we load it onto the vessel tonight.
And there we have it, full power. This old girl is ready to go back down.
The dial indicator gauge must be secured. We'll use this torque wrench for the structural assessment on the fuselage tomorrow.
Ensuring the integrity of the primary regulator is critical. Once the seals are checked, the gear is secured for transport to the site.
All right, the dive team is ready. We have the heavy lift cables, the sonar array, and the stabilization harnesses secured. We are good to proceed.
We've completed the initial assessment on this section. Now we're preparing the specialized tools for transport to the main structural analysis bay. The torque wrench isn't gripping the bolt. It appears to be fused solid with the corrosion. This WW2 mortar foundation is a significant discovery. We're logging the coordinates now before the recovery operation begins.
Cable secured to the foundation. Tension looks good. Proceeding with the survey. Over.
We've located the main artillery piece. The corrosion is heavy, but we're starting the cleaning process now to identify the serial numbers.